So dear students, similar to the last video, the way we use the wave equation when it is propagated through a lossless medium. So now we are coming to the point that now the wave is propagating in a conducting medium. So the wave equation becomes del square E minus mu epsilon plus E by t square minus mu sigma dE by dt over c. This is the wave equation when it is passing through the conducting medium. Now we need to convert this to phasor form. The easiest way to convert an algebraic differential equation to a phasor form is, the last class I discussed the technique. So replace with an omega square or with an omega. So now, so this is a j omega. So this is with a minus omega. So this is how this and now, so again we can replace minus omega square as, so minus 1 into omega square, whereas minus 1 is j square omega. So this one becomes, so equation number 1 becomes delta square E minus, so dot square by dot square is nothing but j square omega square, so omega square j square E minus mu sigma dou E by dou T is dou by dou T is j omega into E equal to C. So see the changes. Instead of this one we use this, and here now take the common terms. Take the common term. So the common term in the here are j omega mu. So j omega epsilon plus sigma into E equal to C. So now we simplify this expression. We will take, we consider this as gamma. It's a propagation constant. We will take it, this as equation number 2. So 2 we can rewrite as del square E minus gamma square, sorry, this is gamma square, just like beta square, gamma square E equal to 0. So gamma equal to j omega mu and within the bracket sigma plus j omega epsilon. So this is gamma square. Now multiply j omega mu inside the bracket. So this becomes j omega mu sigma plus j omega, that's minus 1 omega square mu epsilon. So gamma square becomes minus omega square mu epsilon plus j omega mu sigma. Gamma square has two parts. So one is the real part and one is the imaginary part. Now let us take what is the gamma. So this is gamma square. So gamma becomes square root of. So gamma has, let us take gamma in the form of a complex function, and it has one real part and imaginary part. Let us take gamma equal to alpha plus j beta. Now we square on both sides. So let us take, this is equation number 3. So we are squaring equation number 3 on both sides. So this expression becomes alpha plus j beta whole square. So alpha plus j beta whole square is alpha square minus beta square plus 2j alpha beta is equal to minus omega mu epsilon plus j omega mu sigma. So here this is the real part and this one is the imaginary part. If you look at the right hand side, this is the real part and this one is the imaginary part. Now we get both real and imaginary parts on the both sides of the equal symbol. So alpha square minus beta square is equal to minus omega mu epsilon minus omega mu epsilon. Similarly, 2 alpha beta is equal to 2 alpha beta is equal to this term omega mu sigma omega mu sigma. So sorry, there is a slight mistake. This is minus omega square. This is so minus omega square. So here also minus omega square. Now I am going to use another quadratic function just to use minus alpha beta square and 2 alpha beta. So for that I am going to use alpha square plus beta square. So alpha square plus beta square is alpha square minus beta square whole square plus 4 alpha square beta square square root. Now alpha square plus beta square is equal to, we know alpha square minus beta square. This is equation number, let us take it as equation number 4 and this equation number 5. Substitute 4 and 5 here. So this becomes omega power 4 mu square epsilon square plus 2 alpha beta whole square, that is omega square mu square sigma square. So now let us take it as equation number 6. Now add 4 and 6. So 4 is alpha square plus beta square, 6 is alpha square plus beta square. So this becomes 2 alpha square is equal to minus omega square mu epsilon plus square root of omega power 4 mu square sigma square omega square mu square sigma square. This comes in the. So from this expression alpha equal to omega square mu epsilon by 2 plus, here we can see there some common terms. Omega square is a common term, mu square is a common term. So we can take out omega and mu, and also we can take this for simplicity we can take this out. So this becomes omega square mu epsilon all divided by 2 is equal to square root of 1 plus sigma square by omega square and epsilon square. Now you take the square root of the entire function. Now if you look at this expression here, you can see some common terms, and to pull it out, so alpha become omega, you can take it out again, so mu epsilon by 2 1 plus sigma square omega square epsilon square minus 1. This will come inside the root. This alpha is called attenuation constant. Because when electromagnetic wave propagates through a medium, a conducting medium, its amplitude slowly decreases. Similarly, there is also a decrease. There is a difference in the phases between adjacent wave shape. So that is indicated using beta. So now we obtain the expression of alpha, and the next term is phase shift constant. So propagation constant has two parts, attenuation constant and phase shift constant. And now let us, in the similar way, we can find the expression of beta. So if you look at equation number 4 and equation number 6, you subtract 4 minus 6. You subtract 4 minus 6, you will get 2 beta square. So 2 beta square. So 4 minus 6. So this is become minus 2 beta square. So this will become minus omega square mu sigma and minus omega power 4 mu square sigma square plus omega square mu square sigma square that will come in square root. So from this expression we can find what is beta. So beta is same as that of alpha. The only difference is it is very easy to remember the expression of alpha and beta. If you know alpha, the beta is omega mu sigma by 2 1 plus sigma square omega square small square. So close this bracket and let us go to the square root. Now if you look at the alpha and beta, the only difference is this one. So if you know the value of alpha, if you know the expression of alpha, mathematical expression of alpha, it is very easy to recall the beta. Just replace the -1 with +1. So finally we obtained what is the attenuation constant and what is the phase shift constant. So the propagation constant, the gamma is expressed as a constant, as a complex function, alpha plus j beta, where alpha is attenuation constant, whereas beta is the phase shift constant. So attenuation constant is like the damping of the waveform. So just you see that this will be like this. So as it propagates through the medium, so there is its magnitude is slowly coming down, and whereas beta, the phase shift is just like it is not maintaining the same phase. So let us take this is the phase difference between the first peak and second peak. But if we move forward, the phase shift at one stage of this propagation will be different from the previous stage or the later stage. So so we can observe two types of changes. One is amplitude will diminish, and there is phase also will shrink. So these are the changes we can observe when an electromagnetic wave propagates to any medium. So that we mathematically expressed with alpha plus j beta as a complex functions. So we finally derived the expression of alpha and the expression of beta. So this is the end of this topic. Thank you.